All right, so just in terms of what we're going to cover, we're going to briefly go through, so what is this thing called AI? Because, as Tony said, it's a bit of a fuzzy term, it's poorly understood. We're very, very briefly going to discuss what KM is, right? Then we're going to talk about some specific applications of AI that are cropping up all over the KM space, right? Then we're going to talk about some of the ethical and governance issues here, which I think Tony kind of alluded to right at the end of his talk, right? And then we're going to talk about the challenges, the next steps, and what do I as a manager working with these things do? Okay, all right, so let's start with that question. What is artificial intelligence? Here is Cyro's definition, okay? It's the name given to a range of technologies that some exhibit some characteristics of human intelligence. Awesome. What does that mean? Right? Okay, so I'm going to offend a few people here. I'm just going to bundle these three terms together. I'm going to treat them as the same for the purposes of this talk. Right? Artificial intelligence, machine learning, cognitive computing. Now, what these things boil down to are basically three things. One, data, quite a lot of data. Two, algorithms. So algorithms being computer programs that take the data and do something to it, right? In a repeatable, cyclable way, okay? And then failure, right? Because typically what you're doing with this is you're learning from what you're doing, hence the term machine learning, deep learning, right? And a key part of learning, as we all know, is failure. So let's just call that iteration because that's much less painful than failure, okay? So a key thing here is we've got data, we've got algorithms, we've got doing things over and over again, all right? Okay, yes, but what does that mean, Matt? Right? So this is a model from Amazon. It's very nice, it's very simple. It's really about supervised machine learning, right here. So what it says is, first of all, you get your data, right? And then you have to clean your data. And if you talk to any data scientist, a good 80% of any of the part of the work they do is actually getting the data in a fit state to process, right? So what does that mean? Okay, well it means, okay, if we're going to multiple data sources, do all the fields mean the same thing? Does title, let's use a really basic sort of information management one. When we say title and when we say author, are we talking about the same thing? Are we treating them in the same way? Okay, so you have to clean your data. If it's been collected, through sensors or through surveys, how reliable is it? Right, because typically data there's noise enters the system, it gets messy, and then you might have to normalize it. So it might come in lots of different formats, and you might have to align it. You might have to make sure it's all in the same data ranges, because sometimes algorithms get picky about that. So you have to spend a lot of time cleaning, right? You've got to prepare it so it's all ready for the model to use, and then you have to do some training, right? So typically with this model, what we're saying is we want this system to learn how to do something, right? To say, recognize a face, right? So what we do is we get lots of pictures of faces, right? And maybe some pictures of non-faces as well if we're feeling clever. Then we take a subset of those and we feed them into an algorithm, right? And because this is a supervised learning example of machine learning, we go, okay, how many of those did it correctly recognize as a face? Right? And we feed that back into the model, because this is iterative, remember? So each time we feed it back, we get better at doing this, right? So we're doing this, okay, we're recognising faces. Fantastic, we're recognising faces 60% of the time, 70% of the time, right? So we're then evaluating the model. Now, we haven't put all our data in there, right? So we've trained it, and then we've kept a portion aside to test it. Okay, so if we put the testing in, right, does it actually recognise them correctly? All right, so then we've kind of trained our model, then we deploy to production. So as we say, okay, from now on we're going to use this model to identify faces as they come on, right? And this critical bit here, we're going to monitor what happens, right? And we'll talk about that in a little bit. Is this making sense so far? Is this too simple? Is this too complicated? About right? Okay, all good. Excellent, thank you. Right, yes, Matt, but what does that mean? So these are some of the words that, I think there's some overlap between one of Tony's final slides and this. These are a lot of the terms that are used, or people throw about when you're talking about machine learning. right? So things like linear regression, which is a statistical term, decision trees, which is a form of algorithm, right? So some of these are kind of quite low level. Then we start talking about things like fraud detection and image recognition and natural language processing, right? And that's more about the outcomes that we get from when we use these techniques. All right. Okay, Matt. So what's it not? Right? Has anybody seen this joke before? Okay. So, shall I explain the joke? Because that's always great for a joke, right, to explain it. Okay, so the original Star... Can you tell me the original Star Wars quote, by the way? That's no moon! Exactly. What is it? A Death Star. Right, so that's no AI. So when vendors talk to you about artificial intelligence, right, sometimes they are talking to you about a rules-based system. If you get this input, then you get that output, right? It is absolutely predictable, or should be, in terms of how it behaves. And you can make those quite complicated, right? So you can put in lots of if-then statements, okay? And you can do things like create these very complicated Boolean searches to classify documents if you want to, right? Based on where the word appears in the text, how many times it occurs, what other words it appears adjacent to, all that kind of thing, right? So if you look at something like Microsoft's data loss prevention tool, right, which is supposed to stop you sending people's credit cards all over the internet, that doesn't do it through whiz-bang machine learning. It does it through identifying text strings. It says, does this have the number of digits you would expect to find in a credit card? Okay, so not everything that badges itself, artificial intelligence necessarily uses these learning techniques. Does that necessarily make it bad or useless? No, right? So I think sometimes we get hung up on the only good stuff is machine learning, right? No, it's a tool in the tool set, right? And like rules-based tools are very powerful, especially if you don't have any data in the first place. Because as you remember from this slide, right, you can only do things like machine learning if you've actually got data to work with. Whereas rules, you can apply them to anything. Okay? So, AI is about more than just if-then statements. All right. Again, what is it not? So the things I'm not going to talk about here are analytics. Again, it's something else that kind of gets bundled with artificial intelligence. Don't get me wrong, I love analytics. But generally, they're about describing what's going on. They are, even when you start using predictive analytics, you might not necessarily need to use machine learning algorithms there. You might just be using rules, right? The other thing is robotic process automation, okay? Now, robotic process automation does not sadly involve robots. I was very disappointed when I found this out. Has anybody got a robotic process automation tool in their organisation? Hands up, please. We've got one down here. Okay, one over there. So basically what it does, it's a bit of software that mimics a human, right? And typically you use it to link together old out-of-date IT systems that it costs too much to integrate or replace, right? So the piece of software pretends to be a human, it keys in the data, it takes out the response, and then it passes it on to the next system. Now, these things they're not artificially intelligent, but they can still be very, very powerful if you do them right, okay? Where they fall down is where they start getting responses they don't expect, because they're deterministic, right? They're working on if-then statements. And in some cases, they're actually working on the particular anchors around the field on that screen, right? So still very powerful, still worth looking at. I'm not going to talk about them today, right? I said these things are not machine learning or artificial intelligence, but both of these things may be combined with AI in a solution, right? And bringing them together often makes them more powerful. All right, okay. Why now? So artificial intelligence, machine learning, it is so hot right now. It's probably up there with Marie Kondo, right, and Olivia Colman, say, right, in terms of its hotness. In fact, so I do a seminar series at UTS. We are doing a session on machine learning on the 2nd of April in the evening. It's free. Normally we get about 100 RSVPs. We got 300 to this one, right? So hot right now. Okay, so why is it hot? Okay, so a few things, right? With machine learning, size does matter. Okay? The amount of computing power you need to do it is often quite heavy, because whilst the algorithms might be simple, you need to do them a lot of times, or you're dealing with really big data sets, okay? Right, so you need computing power. And we seem to have crossed the threshold where computing power became available to do this in about the early years of this decade, right? So Moore's law kind of came to our rescue. The next thing is you need data to do them, right? So as I said earlier, you can't do machine learning without having a nice big data set to work with, preferably one that's been properly categorised and had some work done and made tidy, okay? Right, and what's happened in the last few years is because data storage has become, not just compute, but data storage has become so cheap, we can afford to keep lots of data we used to chuck out, right? So I'm sure all your organisations are going through digitisation initiatives and that kind of thing. So you're taking things that were analogue and inaccessible and making them digital, right? Which is actually quite exciting, because the first order benefit is you don't have to store the paper, you can chuck that out. But the second order benefit is you can start applying all this good stuff to it, right? So for example, Google Translate, like the early versions of that were based on the UN Parallel Corpus. So the UN, I think it's 6 different languages, I could have that wrong. Basically, all UN documentation has to be in multiple languages, okay? Which gives you a huge data set to work on. So Google kind of fed that into a machine learning algorithmic environment and said, okay, based on this, we can start doing translation now, right? But they couldn't really do that without the language sources to kick that off, without the source data, okay? Now, the final thing is the availability of algorithmic tools, right? So you can get this stuff as easy as you can buy a tin of baked beans from Woolies, right? Open source. Google made a whole bunch of their algorithmic tooling free under the TensorFlow label, right? Or if you're using as a service cloud environments like AWS or Azure or whoever, right? They will put that in there for free or for a minimal cost. Why? Because they want you to put more data in there, right? But increasingly, you don't need a PhD in mathematics to get your hands on these tools. Now, you still need nous in terms of how you use them and deploy them, but you can get them easily, right? And there are big public examples of organisations doing this, like Google, like Facebook, like Amazon, right? And following all this, there is now a greater awareness among both computer developers and decision makers, people with checkbooks, right, to actually get involved with this stuff. There's quite a lot of hype around it. All right, so that's why now. Okay. I want to keep this very short. People have seen this before. Has there been much discussion of dear old 30401? A little bit? Been a little bit of discussion? Yeah? Okay. What do people think? Has anybody read it? Hands up if you read 30... Stuart's read 30401. Gold star for Stuart. What do you think of it, Stuart?
A lot of it is pretty standard for what a lot of people are probably trying to do in the room, but the emphasis on leadership and on culture is really powerful. And so if you're having troubles getting leverage at the top level of the organisation, I think that's your way to say, listen, you know, it doesn't work without this stuff. We need to pay attention to an international experience.
I think that's a really good point, right? Things I would say is it's very short, right? So, like, standards are not always cheap to buy, but once you've got it, you can read it in half an hour, okay? If you work in an organisation that is quite regulation orientated, or standards are an acceptable way of doing things, it is a very useful way of starting the conversation. It's not especially groundbreaking, but it's good, solid stuff. I would call it mostly harmless, right? And if anybody gets that reference, then I love you because you're as big a geek as I am. Right, okay. So knowledge management, yes, but what is knowledge management, right? So realistically, what it means is you end up managing documents. Hands up here who manages documents. Higher, be proud of yourselves, come on. Okay, we've got some document managers, fantastic. Or you're facilitating people, so you're encouraging the sharing of knowledge, the transfer of that. Hands up who's doing that. Okay, so we've got a good bunch of people doing both, right? Sometimes what it does boil down to is, can you get people to use Office 365, please? We've spent a lot of money on it. Okay, some laughs of recognition there. Right, interestingly, historically, it has not included the management of data. Typically, you've had your knowledge and information management people over here, and then your data management people over here, and everyone's kind of got along doing their own thing, right? And increasingly, that's not tenable, right? And I think there's a number of reasons for that. I think given the amount of push that's going around technology, I think it's kind of bringing these people together. And also, you are able to do things with documents and text that historically you could only do with numbers, right? And that's changing things as well. And that means that people that used to work with numbers are now getting interested in text, which is quite exciting. So I think there's lots of opportunities there to have new conversations across those disciplinary boundaries with people, right? And that means that knowledge managers and information managers have to learn some of that data language if you don't know it already. And then vice versa, we have to start educating the likes of data managers around how words work and how people think and all that kind of stuff, right? So lots of opportunities there. Okay, all right, so interesting piece of research that came out of the AIIM at the end of January, right, where they were saying, okay, people that are using artificial intelligence in the document management world, what are you using it for, right? And it's okay. It's what you might expect for something that's still new, that's not quite there yet, right? So they're using it for data loss prevention, right? How do we stop people sending information out of our organisation deliberately or on purpose? How do we prevent people from stealing stuff? Cybersecurity, also really hot right now, but nobody wants to talk about it in public, right? Identify the underlying content of a document. So there we start to talk about semantic analysis, right, that Tony was talking about earlier, right? Intelligent capture to identify or index content documents while scanning them, and then automatic text analysis. So a big emphasis on text analysis here, right? When I look at what's going on in the marketplace and what people are talking about, I find at the moment it falls into two main areas, right? So those things that the AIIM were just talking about, which is that auto-classification piece, which you might use to try to enrich your enterprise search, right, or for document processing, right? And then the other area is around conversational interfaces, right? And that's things like chatbots, voice search, using tools like natural language processing, that kind of thing, right? That seems to be another area where there's been quite a lot of stuff built that can be leveraged, and there's a big push at the moment because what do chatbots mean? Fewer call centre staff, right? And chatbots are often the front end of a robotic process automation system as well, right? Okay, so let's talk about a couple of examples. Auto-classification, right? Just very quickly, it's using machine learning, right, to classify documents so you don't have to get people doing it, right? And classifying those documents might trigger actions like security settings, like distribution, disposal, redaction of sensitive content. That's quite a big one in professional services and legal, right? And also, like I say, frequently to improve the search experience. And we'll come on to search in a bit later, because I think there's something important there, right? I think the other thing to mention here is 5 years ago, you pretty much had to do this by yourself, and that required you to have a certain size of organisation and a certain budget. Tony talked about having 10 data science staff. How many people in this room have 10 or more data science staff on their workforce? You must, Brian, come on. Okay, we've got one, we've got two, we've got 4 people. That's the minority of people, right? Hands up who's got at least one data science person on their workforce. Okay, that's still less than half, right? So the rest of you can't really do this stuff by yourself, but increasingly vendors are offering to do it for you, right? So AWS and Microsoft Azure are packaging that thing into their packaging AI and machine learning algorithms into their systems, but your document management providers will increasingly be offering this to you as part of their offering, right? And there's some things you need to think about when that happens, but we'll talk about that in a little bit, okay? So let's talk about an example, right? So who here has heard of who here has seen the case study from New South Wales State Records before? Got somebody at the back, switched on. So really, look, this event I've got in April, I've actually got Glenn Humphreys from New South Wales State Records coming along, because I think his work is really interesting, and the quality of the actual case material that he's providing is just fantastic, right? In terms of this is what we did, right? This is what happened, right? This is what we've learned from it. So just briefly, they took, and all this information is publicly available if you want to find it, right? They took about 100,000 digital files and 21,000 paper files, right? They classified it against a retention and disposal authority, which all you records managers will be quite au fait with. They did it, interestingly, they didn't do it in the cloud because they had concerns about data ownership, but they had enough compute and storage on site to do it themselves, okay? And then they used some like off-the-shelf text extraction and an algorithm that they got from the scikit-learn site, which is all open source, okay? They did 2 pilot projects, and then they got quite promising outcomes, right? So they got 70 to 80% accuracy. That's not bad, right? It's not perfect, but it's better than nothing, okay? Now, a couple of points that Glenn made I think are really, really important that I want to highlight. So the first is there is a need for both specialist ICT and data science knowledge as well as subject matter experts. So basically people that understand how those algorithms work and which algorithms to apply. You don't want to use a clustering algorithm to do a classification algorithm's work. Right? You don't want to confuse correlation and classification, those kinds of things. Okay? And then the final thing, again, which we've been saying repeatedly, the need for a large data corpus that is well labelled and representative to train the model stood out as being imperative. So to do this, you actually need data, in this case, data that's been classified, to train the model with. Otherwise, it's not going to work. Right? So again, there is work required here, and there's a certain level of maturity around managing your data that you need to have before you can start doing this. Is this kind of making sense so far? Yeah. Awesome, thank you. Okay, chatbots, conversational interfaces, right? Right, these are pretty much a combination of a bunch of technologies, including machine learning ones. You've got natural language processing, right? So in other words, getting the machine to be able to analyse what somebody is saying, right? And then typically you then have to plug that into some kind of back end, right? Who here's got Siri or Alexa? It must be most people. Google Home, that kind of thing. Yeah? How do people find that? Got thumbs up? Any people not like it? Why thumbs down from Stuart?
I think I've used it probably 25 times, and once it's given me a legible answer to the question. I suspect I have a bad accent.
Look, I think there's also, so there's something there about, I can't remember the exact term, but it's something like bound versus unbound use cases, right? So the thing about Siri and Alexa is they cover everything, right? Whereas if your chatbot is just focused on IT service desk problems, it's dealing with a much more contained space.
You just have to use it to turn it on and off Netflix.
Pro tip there.
Watch this show on Netflix and then it just turns on the TV.
I don't mind if it gets it. It's just when you make a call, call Jen, and it calls my boss. It's just.
Look, you've probably had some lucky escapes there, Stuart, frankly.
Yeah, I agree. I mean, you're in my phone list, so.
Okay, I think we had some other comments going on. Tony.
I think the only thing I want to raise is they're listening all the time. And
fair
so
call.
It is unclear how they capture the data and how they store it, and from an organisational point of view, there's an inherent risk there.
Absolutely.
I think it also depends if you can think about the data sources that a tool like Siri is going to have access to. So some things you can get Siri to give you a straight answer.
Yep.
Sometimes she'll say, "Oh, Brian, I found a link for you," and understanding that. And then the other thing is if you frame your question to Siri in the way that Siri would prefer, as though you were talking to a computer, and think about how it's going to go away and do the job and then come back to you, then you get a higher result than just trying to chat to
I
us.
tried to book a flight and I used one of the, I think it was, I can't remember, but it was a chatbot. And I got halfway through the process and going, oh, I'm not using this again. So guess what? I don't ever use them because of that first time.
Oh, that's a really important point. We'll come to that in a moment. And just to your point, Brian, so you are training Siri, but Siri is also training you.
Yeah. So I've used Siri probably 1,000 times, and I've got a lot of value from it because I had an instance where I needed to do basically 2 days a week work for about a month, and so Siri was the only way I could do it. So I had to stop typing and start talking, and so I really had to make it work for me, and I worked out what she was really good at, and she was profoundly useful.
In a specific domain, right? Right. And that kind of links to what you're saying as well. Okay, so a lot of websites have implemented chatbots, not necessarily voice-based, sometimes text-based. Okay, NAB, I think, was one of the first big one in Australia. They're also being used inside organisations now. So the big example that's being touted around is Liberty Mutual's chatbot. Now, again, like I say, most people don't like to talk about this, but Liberty Mutual have spun off their internal employee-focused chatbot as a separate company called WorkGrid. So yes, they want to talk about this a lot. Okay, and it's an interesting product, right? So again, the ROI from this typically comes because you're reducing things like contact center, right? Chatbots work well for simple questions and answers. How do I reset my password, right? That point you made about the first experience is really important because if they don't work, then people go off them real quick, right? But that means you need to have an understanding of the questions asked, how they are asked, the correct answers sourced, and how these answers should be best delivered. So there's actually a lot of work that's required to set up a chatbot, okay? And like I said before, the back end needs to often plug into other information sources, right? So you have to take those words that people say or type and then type them into something that you can turn into an API call to another system, such as a document management system, right? And we get to the point where the technology for chatbots is actually fairly mature, even if you do need to be careful about use cases, right? So they are very much getting ready for prime time. Okay, AI ethics. So people like Elon Musk, and this is a picture of Elon without his skin suit on, talk a lot about AI ethics in terms of artificial intelligence taking over the world and wiping out the human race. And I can see some upsides to that, but right now I don't think that's our biggest concern. And what worries me about those discussions is they neglect things that are concerning and we do need to worry about, right? Now, this is a New Zealand gentleman called Richard Lee, okay? Now, he wanted a new passport, so he uploaded a photograph of himself to the online passport tool from the New Zealand government. And what did it say? The photo you want to upload does not meet our criteria because the subject's eyes are closed. As you can see, Mr. Lee's eyes are clearly open, right? So yes, that algorithm is a racist dick. Right, but why has it done that? Okay, so it has done that because it's largely been trained on white people's faces. Okay, now when it comes to a face it doesn't recognise, it assumes there is something incorrect with it. Right? So, we talked earlier on about training data, right? We need to think about where that training data comes from and whether it is representative of what we need to be processing. Because if it is not representative, there will be repercussions down the track for edge cases, right? For people or things that don't fit in with those criteria. All right. Now, this is not just limited to this particular example. It's chronic, right? You find it in terms of, Google's image search actually, doing horrible things in terms of images of black people, right? Amazon themselves had an issue just before Christmas. So they created an algorithm that would work out how successful you would be at Amazon based on your CV. And if you had a woman's college on your CV, it said you wouldn't be successful. Right? Now, that's because Amazon managers have basically been a bit sexist, right? And that behaviour is then getting embedded in the algorithm and not being challenged. Now, to their credit, they recognise this and never put this into production, right? But nevertheless, people have this image of machine learning as, because it's machines, right, as being objective, without human bias, right? And that's often not the case, because the data it starts from comes from people. And I don't know if you've noticed, but human beings are awful. Right, again, my previous comment about him, right, and wiping out the human race, okay? So yes, we are sexist, we are racist, we make snap judgments of people, right? We do lots of terrible things. This has been embedded in our historical data that we've collected, and if we're not careful, it's going to be passed on into the world of machines, and we'll go, oh, too late. It's all the machines now. So, Alan Finkel, the chief scientist of Australia, has said that what we need is an agreed and clear signal so that we individual consumers don't need expert knowledge to make ethical choices, right? So what he's saying is we need a trust mark, we need a Turing certificate to say that our artificial intelligence is not going to shaft us, right? I think there's something in that idea, and I think more broadly, as information managers working with these things, we need to think about governance and responsibility, right? And again, I will kind of probably finish on that. All right. Okay. This is probably the one original part of my talk, right? Okay. So, who here has an enterprise search engine? Hands up, please. Hands up. Hands in the air. Come on. More of you have got an enterprise search engine. Keep your hands in the air if it works. If it's awesome. Okay. One person. Sweet. Okay. They do exist, right? There are people that have implemented enterprise search well and get good results from it. Typically, it requires a lot of work, right? And I want to think about enterprise search as a paradigmatic example, as a kind of forerunner for machine learning and what it means for us, right? So here are the things, right? We know how to implement enterprise search well. There's a great book by Martin White called Enterprise Search that pretty much tells you everything you need to know to implement enterprise search, right? The tools are there, they're good. Everybody thinks they're terrible, but they're not. They're really good. And they're pretty much commoditized now. With things like Solr and Elasticsearch, they're open source, okay? Right, but nevertheless, as we've seen from this room, most enterprise search implementations are terrible, right? So those undertaking it do not know what they're doing, right? It is viewed as purely a technological implementation. We put the search engine in, we turn it on, it does all the indexing, sweet, right? We don't have to think about how people are using this, what they're looking for, why. We don't have to think about their context, right? People give up too easily because this is an iterative process, right? Because enterprise search engines, when you think about them, what are they? They're a large amount of data, right? From files with text in. They are algorithms that then process and prioritise that data, and ideally they are iterative, because the first time you implement them it does suck. It is rubbish, but you have to go through 4 or 5 iterations before it's good. Okay? So what does that sound a lot like? Machine learning. Okay? So, what happens? People give up too easily because they do not see it as an iterative process. They see the first version and go, this sucks, and then throw it in the bin and probably blame the tool, right? Then they blame the technology. And the costs of failure are often hidden from decision makers, right? So if it goes wrong, you go, oh, well, whatever, it's enterprise search, right? And the productivity impacts of that are not seen and not measured, right? So my concern with all the potential of machine learning and artificial intelligence is that we start making the same mistakes that we made with enterprise search, right? We don't focus on the iterative nature of it. We see it purely as a technological issue. The people doing it don't know what they're doing, and then the costs and the outcomes are hidden or poorly understood by decision makers. Okay, right, final slide. Woo! Right, okay, so expertise, right? So if we're going to do this stuff, what do we need to think about? So first of all, expertise, right? Now, you need a mix of expertise, right? You need people with data management skills, people that can take the data and clean it and make it pretty. You need people with some statistical chops that can then analyse it and do interesting things with it. You probably need people with BA and UX skills, right, in terms of understanding what people need and how to present that information to them in a way that they can action, right? So you need a whole mix of people, right? That's probably not one person, okay? It's very rare to find somebody with all that stuff. Or you need a vendor with those skills. So if a vendor comes along and says, I can solve your problem for you, one question to ask them is, tell me about the people that are going to be solving that problem for me, right? And if it's one guy locked in a room like with 1,000 yards stare tapping the computer, it's probably a bad sign, okay? Positioning and integration, okay? Understanding where the AI and the machine learning fits into your broader processes, into what you're doing, right, into your landscape. And then I think this is an important point that Tony made. After you've got it up and running, how do you then operationalise it, right? How do you make it sustainable and keep it going? How do you iterate it, right? So, I think that things like machine learning and artificial intelligence are great if you have an agile product mindset, right? So the first time you do it, it'll suck in the first sprint. The second sprint, it'll suck less, right? Okay, data. This has been all the way through. You need data that is accessible and clean enough to use for this to work, right then. Fit for purpose, again, are the different pieces that you're applying, the different technologies, are they the right ones to use? Right, and then finally, governance, okay? Linking to the ethics piece, right? Do you have the right governance structures in place? Do you know what you're doing? Right? Can you identify if mistakes start to appear in your process? Okay. What happens if something goes wrong? I think the other thing related to that is trust. Okay. So often, to many people, these appear as a black box. Something goes in and then something goes out. How can you trust what goes out? Right. So typically, you need to be able to say, yes, we've run tests on this, and 80% of the time it works. We've actually got things in place to monitor and identify the 20% of times it fails. All right? And then it's the final one there, concept drift. So inevitably, as your context changes and the data that you're working with changes, right, your model will become less relevant. Right? The thing you trained is based on yesterday's data, not tomorrow's. So therefore, you need to be monitoring what you're doing and tracking whether your model still accurately represents reality. Okay, and that's part of your governance process. So with that, I'm going to stop and just say, look, this is a really exciting space. I only see it becoming more important and offering more opportunities for the people in this room. And I would encourage people to get their hands dirty if they can. Thank you.